Hello and welcome to Maths with Mr Amison. In this video we'll be practicing how to convert recurring decimals to fractions using algebra, and the algebra part is really important. I'm going to start by showing you how to do 3 different questions, then letting you copy them down and have a go yourself. So for the first question, we have 0.7 recurring, or 0.777, etc. When you use algebra to convert recurring decimals to fractions, the first thing you always need to do is let x equal your original recurring decimal. So we let x equal 0.7 recurring, and I wrote that out as 0.7777. Now, because there is one digit repeating over and over again, if I multiply x by 10 to get 10x, then it moves all of the digits one place value to the left. Each digit becomes one place value bigger, but because each digit after the decimal point is exactly the same, I'm replacing each 7 with a 7. I'm moving each 7 to the left 1, so the numbers after the decimal point don't actually change. We still get 0.7. Still get 0.7777, just with a 7 point in front of it instead. So it means if I do 10x take away x to get 9x, that's 7.7 recurring, take away 0.7 recurring, the digits after the decimal point cancel out. So we end up with just having 7 take away 0, which is 7. So I end up with 9x equaling 7. So x, therefore, if I divide both sides of my equation by 9, is equal to 7/9. And therefore we have shown that 0.7 recurring is the same as 7/9. And you can try that on your calculator if you want. 7 over 9 on a calculator equals, press the SD button, and it will show you that 7/9 is the same as 0.7 recurring. 0.37. Again, we let x equal 0.37 recurring. This time the 3 and the 7 are all repeated. We've got 0.373737. Because we have 2 digits repeated this time, the 3 and the 7 are both repeated. If I multiply by 10, the numbers after the decimal point would not be the same. It would be 7373. So it would be 73 recurring rather than 37 recurring. But if I multiply by 100, you can see that the digits after the decimal point, 373737, this time the digits after the decimal point are 37 recurring, the same as x. Therefore, if I do 100x take away x, it's the same as doing 37 take away 0, because the digits after the decimal point cancel out. So 99x is 37. I can then divide both sides of my equation by 99 to get x by itself. To get x is 37 over 99. I can do similar for this next question. Here, notice that the 3 and the 7 repeat over and over again, but we have a 4 as well there. So what I'm going to do, I'll call it x, and then I'll multiply by 10 to get the digit that is not repeating on the left-hand side of the decimal point, and the digits that are repeating on the right-hand side of the decimal point. So I have 4.37 recurring. Here again, because we have 2 digits repeating over and over again, if I multiply by 100, that moves each digit 2 place values to the left, and it means that the digits after the decimal point repeating are in exactly the same place, the 37 recurring. So if I do 1000x take away 10x, you'll see that that's the same as doing 437 take away 4, because the digits after the decimal point cancel out. So I end up with 990x is equal to 433. I can then divide by 990 to get x is 433 over 990. Make any notes you wish to on that, then have a go yourself at the questions on the right. Alright, so to convert 0.5 recurring to a fraction, x is 0.5 recurring, so x is 0.5555 and it carries on. So 10x would be 5.5555. Again, 10x because we have one digit repeating. So 10x take away x is 9x, which is the same as 5 because it cancels, it gets rid of the recurring decimal. So x is equal to 5/9. 0.52 recurring, we have x is 0.52 recurring. 0.525252 carries on. Here we have two digits repeating, so if we multiply by 100 instead to move our digits two place values to the left, because there are two digits repeating, we have 52.5252. If we do 100x take away x, we are getting rid of the recurring decimal part, and it's the same as 52 take away 0, so 99x is 52. If we then divide by 99, we get x is 52 over 99. For 0.652 recurring, where the 5 and the 2 are repeating, we have x is equal to 0.652525252. Because we want the non-recurring part on the left-hand side, if we multiply that by 10, we get 6.525252, or 6.52 recurring. We have two digits repeating over and over again, so if we multiply that by 100 to move all of our digits two place values to the left, 1000x is 652.525252. And then we can do one take away the other, so 1000x take away 10x to get rid of the recurring decimal part of the decimal, to get 652 take away 6, which is 646. So 990x is 646. So x is 646 over 990, but you have to be careful to look out for fractions that simplify. Generally, you need to look out for fractions that are divisible by 3 or 9, or if you have 900, anything with a 0 on the end as the denominator, fractions that divide by 2 or 10 as well. Alright. So, 6 questions for you to try. Question 1, 2 and 3 are quite standard. Question 4, 5 and 6 are a little trickier, and you may have to simplify a little bit more for those questions. Have a go. So here are the answers to those questions. 0.4 recurring is 4 over 99. 0.04 recurring is 4 over 990, which makes sense because it is 10 times smaller than 0.4 recurring. And 4/99 divided by 10 is 4/990ths. And that simplifies to 2 over 495. 0.14 recurring, where the 1 and the 4 are both repeating, that is 14 over 99. 0.14 recurring, where just the 4 is recurring, that is 0.1444, etc. That is 13 over 90. So similar to part A, but a little bit different. 0.34 recurring, where the 4 is repeating, not the 3, so 0.3444, etc. is 31 over 90. 0.34 recurring, where the 3 and the 4 are repeating, is 34 over 99. And it's interesting to note that for the 0.14 recurring, where the 4 is repeating, this digit here was 1 less than the 4, and the 1 was the first digit. Here, the 1 is 3 less than the 4, and the 3 was the first digit. So there's a link there between the two. But also, the 1/4 recurring and the 3/4 recurring are very much linked. If both digits are repeating, if we have two repeating digits, we're going to get something over 99. If you've got no digits that aren't repeating after the decimal point as well. So here we have 0.35 recurring. You could have guessed from 0.34 recurring that we would get 35 over 99. 0.357 recurring, we have the 3, the 5 and the 7 all repeating, and it follows the same pattern. We get 357 over 999. But that simplifies as the numerator and denominator both divide by 3 to get 119 over 333. Question 5. Here we have our first questions here where we have a number that is bigger than 1. We have 3.63 recurring, where the 6 and the 3 are both repeating. In this case, we get 630 over 99. If you had multiplied this original by 100, you would get 363.63 recurring, and then you could do one take away the other, and you would end up with the correct answer here. For part B, we have the 6 and the 3 recurring. Again, we still have 3, but the 6 and the 3 have moved have both moved one digit to the right, so it's 3.0636363. The 0 is not recurring, so I would originally multiply x by 10 to get 30.63 recurring, and then multiply that by 100 because you have two digits, so 3063.63 recurring. One take away the other would help you with getting 3033 over 990. And then you can divide the numerator and denominator by 9, noticing that the digits of the numerator add up to 9, or if they add up to any multiple of 9, it will divide by 9. For question 6, 0.771 recurring, where all of the digits repeats, is 771 over 999, and that simplifies to 257 over 333. The original recurring decimal in this case would be 0.7717717771, etc. For part B, we have a slightly different answer, although it is very close. Here we have just the second 7 and the 1 repeating, which would be 0.7717171, etc. Which in this case would have to multiply by 10 first to get 7.71 recurring, then multiply by 100 again to get 1000x is 771.71 recurring, and you can go from there to get that our fraction is 764 over 990, which simplifies to 382 over 495. Thanks for watching. I hope you found it useful. I know converting recurring decimals to fractions using algebra is a fairly tricky thing to do, but the more you practice it, the better you'll get. Bye for now.